stack the deck.
One for me, one for you.
It's like, yeah, how did Michelle win all those prizes? She must have visited a lot of the booths. Okay. Welcome, everybody. My name is Jim Spishiger. I'd like to welcome you to the 2018 Inspection Division Conference. This is session C1. This is a product tutorial. We will do two tutorials in this session. So the first speaker will be Nate Beckrich from CyberOptics. He's been in the business for 10 years. So I will turn it over to him. Thank you. Just a reminder, you'll get a lottery ticket or a raffle ticket for door prizes. So see me, and I'll make sure you increase your chances to win. Thank you.
Thanks, Jim.
Thanks, Nate.
Well, thank you for coming, and good to see you guys. Welcome to everybody viewing via the web. My name is Nate Beckrich. I'm with CyberOptics Corporation. Wanted to talk to you a little bit today about a product that we've created and launched recently. And before I get into the product, though, I'd like to give you a little background about our company, who we are, what we do, and why we've found it a need to create this product for the industry. So as CyberOptics, we are a technology leader in optical sensors. We develop our own sensors for sensing in many different applications and industries. We're a technology leader with continued R&D investment. We're technology driven, and we have a global footprint. So we actually are headquartered out of the Minneapolis area and then have a global footprint of sales and support and service around the world. Most importantly, though, we really focus on our significant customer ROI. We want to find out from our customers what they need and then create products that fit that. So the main group of sensors, of course, is very wide. We have different sensors for 2D measurement, 2D and 3D measurement, and also just 3D sensing and scanning applications. So our vision is to be the global leader in high precision 3D sensors. And of course, we fit a few different niche markets and then some general markets as well. So what we were hearing over the years from our customers was we are having trouble on the production floor getting repeatable and reliable measurements from hand tools from different operators. It's tough to train operators and get them built up with skills. We're also having issues in our metrology lab with it taking a long time to get results from a request for inspection. And we can't hire skilled metrologists anymore. It's really tough to find the right people for those roles. We also found out from vendors that our customers are saying their vendors weren't able to provide the right kind of inspection information with their parts. It was tough to do incoming inspection. And so we said, all right, we're going to take all this information that we've heard and create a product that really focuses on speed, accuracy, and ease of use. So we're going to be driving up quality and customer satisfaction and revenue while decreasing time and expense. So introducing the CyberGage360. This is a revolutionary 3D scanning technology, providing the fastest 3D scanning in the industry. We're using metrology grade sensing equipment. So this is something where it can be a measurement tool on or near the production floor, but also providing full 3D scanning at a metrology grade accuracy. It's easy to use, so the operator really only has to press one button to start the scan and get a report out. So we're enabling factory-friendly operation with very minimal training. So now you've got pretty much a metrologist on the factory floor by using the CyberGage at that point. Fully customizable for reporting, so you can do anything from a basic form analysis to a more higher in-depth dimensional analysis. And we'll kind of look at that here as we move along. So operator ease of use, what does that really mean? All they have to do is open the door, place the part in, shut the door, and press the button. And through that process, they're going to get an inspection report. Here you can see some color maps showing visual deviation information as comparing a scanned part to the CAD model. We also have dimensional information included as well, which is something that will generate automatically once that operator puts the part in and closes the door and presses the button. So what's really going on inside is we've actually got two 3D scanning sensors, one on top of the part and one below the part. And we're scanning from one position at a time, but capturing top and bottom information. The bottom sensor is actually going through an optically clear glass plate. So there's zero fixturing involved. Once you place the part in, you don't have to align it or fixture it in any type of way. It'll actually, based on the program that you define, will travel in either 30 or 45-degree increments around the circle or around the 360 and capture those top and bottom scans at each location. So we really have eliminated the need to flip over the part, which is something that makes it very easy for the operator to use. Very simple from a user standpoint of time and also skill. There's no training involved. If they can match the part to what the reference image shows, we can have an easy place the part and press the button, and they get that report out in 3 to 5 minutes. So here's a video showing the actual fringe pattern. Each of those sensors was taking a fringe pattern at 2 different angles on the part. We actually have an advanced mode where we scan at one angle, rotate the fringe pattern 90 degrees, scan at a second angle, compare the two, and then discard any data that doesn't match between the two. So we're getting very high quality data from that process. So again, we're doing fixtureless scannings on all sides. We talked about the form and the dimensional analysis information. On the left-hand side of the screen here is what you'll recognize as scan data. Very high coverage, very high resolution. We can get to 75 micron point spacing. And of course, you're seeing that we're covering more than 95% of the part here. So from a technician and engineering setup standpoint, it's also very easy to use. A little more involved than the operator, of course, but we're telling the system at this point how to look for the part, how many positions to scan, things like that. So the operator has access to 2 tabs, the inspect and the calibrate tab. They can't access the program information, they can't adjust the program or the settings. The engineer would do all of that and verify through the test process. So with regard to the setup on the user interface, we actually have on the left-hand side of the screen, this is our main CyberGage interface in the quick scan tab where we have access to our settings. That includes scan position, so how many positions in one rotation do you want to stop at? We've got a DLP intensity, so that's going to be our brightness of our sensor. We have the ability to do kind of an HDR mode or do an extended range where we do a second projection at a different value. That gives us the ability to scan multi-material parts and get quality reflection of different material types. And then we also have a point quality filter, which is just saying how many of the points that we capture do we want to use for our process, our analysis. And then we've got the point density, which says how close do I want my points? What's my smallest feature size that I want to measure? And how do I really want to, what do I need to have for that point spacing to be able to extract those features? And then the bottom one is the mode settings. So we've got some legacy and standard modes. I've got this set here at the advanced mode where we're doing that crosshatch pattern and comparing the scans and eliminating bad data. On the right-hand side, you'll see the image on the top shows what the reference image looks like. The top left of that image shows where the actual part should be placed. Of course, you place the part in the middle. It matches somewhat close. It doesn't need to be exact, but as you place it on the glass plate, it should be close to where that image shows, and that's a tool for the operator. Shut the door and then press the run button. And here you can see the fringe pattern actually started in the middle screen. And I'm going to play this button here. This is what it would look like. We don't want the operator necessarily watching the scan because they wouldn't be doing something else that we've freed them up to do. But this is what the data would look like, and as the engineer, you're going to watch and verify that you're getting full coverage over the entire scan. So on the right-hand side, you'll see we've captured almost 240,000 points from one angle on a fairly small part here. So we're scanning top and bottom. We're going to continue to rotate around until we get the full coverage that we want. And this scan here took about 3 minutes and 45 seconds. Once we have that scan data, which is on the right hand of this screen, we are going to do a point pair alignment, and that tells us for future scans how to align the scan as the part is on the glass table to the CAD model that's in the coordinate space that you want. So we do a 3-point alignment or a multi-point alignment, and then the scan and the CAD are matched up. And at this point, we can define a datum structure. So we can say, let's define an ABC datum structure. We can then do a datum-based alignment and then follow through with our additional inspection process. So the first thing that we like to do, because if the part's good and you don't necessarily need to program a bunch of dimensions, you can look at what's called a form analysis. This is a 30,000-foot view focusing on where the deviation is from the scan to your CAD. We're calculating the distance between the points captured and the surface normal of the CAD model. Here, as you grow into the warmer colors, your scan or your part is growing away from your CAD. As you go into the cooler colors, you're growing into the CAD. So it's an easy way to see how you may have shrinkage or warpage, or you can even see ejector pin marks and things like that through this process. So we create that form analysis, and then we define features like planes and cylinders, and in this case, surfaces. So we're looking at creating a surface profile measurement on this part right here. So we click on the CAD model, that's our reference, and then we actually, with the aligned scan data, can extract that surface from the scan and show the points used and the output result. So on the left-hand side, that's all the points that are used for the measurement. So you can see there's a lot of points. That's the value of a 3D scan, really, is the number of data points that you're using. On the right-hand side, of course, we've got our result output. In this case, it passed, everything's green. If it wasn't, those points would take on the color of the deviation. From there, we can actually go into our geometry control section, add tolerances. We can do GD&T measurements, things like that. So this is where we would define all of that. And that's very easy. Once that feature is selected, you can go into geometry controls and adjust anything that you want. You can put as much information or as little information as you want in to represent what you're really looking for. So there's one other way to make this very easy for the engineer or technician to set up. And I'm going to talk to you about product and manufacturing information. In some software, it's called model-based definition. But it's where you can actually add in the datums and dimensions and tolerancing directly to your CAD model. So you don't have to go through the manual process to do the setup. Similar to what I just mentioned, it would have all the information that you wanted to add in directly on the CAD file. So when you import that, it looks like this. So all of your inspections done for you. There's no work for an engineer to do any, you don't have downtime on the machine to set this up. You go to the machine, you set up the initial scan, import this file with the product and manufacturing information, and all the data is there for that, that analysis. So the reports are fully customizable. We can have image-based information, some more visual representation of what the deviations are. We can include the annotations. We can include all the tabular information. All of that's able to be included and customized, almost like working in PowerPoint, dragging and dropping, changing the size, doing cropping, and making this something that includes the viable information for the product and for the operator to know that it's good or bad, but not giving too much information. All the information from the project is actually there if you didn't want to put it in the report. That could be saved off and viewed in a free viewer for more of a higher level technician or engineer, or for management to review. So you can see the different ways that we can report here. Different measurement functionalities, anything dimensional metrology-wise that you're really looking to get into, from cross-section dimensioning to 3D dimensioning with basic dimensions, GD&T, all of that's available at your fingertips. So once you have your report laid out and you've got everything in a place that you want it, you press the commit button, and then that saves to the inspection, which on the left-hand side of the screen is the top left tab. That now becomes a part number that's selectable by that operator. Once they select that part number, the reference image shows up, they place the part, close the door, and they're ready to get to work. So by enabling speed and accuracy and ease of use, we've really given the customer improvements in throughput, quality, productivity, operational efficiencies, and saved them time and expense. Any questions about the CyberGage technology at all? Yes, sir. Is it Luke?
Yeah. So what kind of accuracy can this hold?
The accuracy can get down to 7 microns. It's actually, for a 100 millimeter measurement, you've got about a 17 micron accuracy. For a 200 millimeter measurement, it's about a 27 micron accuracy. So most of the time, about a thou or less. Yep.
Another question was, will the software analyze simultaneous requirements without datums?
Simultaneous requirements without datums. You don't have to use a datum alignment to do the inspection if that's what you're asking.
So kind of along those lines, but if so a lot of our prints are colored with just basic dimensions.
Okay.
Which we've taken as a like datum structure. There is no A datum, no B datum.
Okay.
But we're considering it all like datum structure, so they're intended to be simultaneous requirements.
Gotcha. So you can do either coordinate measurements or ordinate measurements. You can define an origin and actually measure from there and have dimensions reported either as the actual length itself or from an origin point. Am I? Maybe I'm not understanding what the simultaneous measurements is, but
Yes, it's
so
we ran into issues with PCDMIS.
okay.
It will not analyze simultaneous such as Smart Profile will.
Okay.
So if we have a hole with a surface profile of 5 thou and say the rest of the part has a 10 thou profile, will it simultaneously check that 5 thou profile with the 10 thou profile?
Yes, it will.
All right.
Yep. And we're using, so our software from CyberOptics, the technology that we've incorporated is the sensing technology. It's the hardware and the motion, and then the integration of that with the with our scanning software. That all gets pulled into Polyworks, and Polyworks is leader in 3D scanning and inspection software. So really what you do is you define, like in this case earlier where I showed that surface profile, you would just define different measurements with different tolerance values for that. You could have the form analysis be at one tolerance level and any different dimension that you were measuring at a different tolerance.
Thank you.
Yeah, you're welcome.
I have a question.
Sure.
Can the software accommodate different revisions of the GD&T standard? So if I have a print that's to one standard and another print to a different standard, would know the difference between those two?
Yes, it would. Yep.
Any other questions? And you have this Cyber 360 available for demonstration?
Yep, it's on the second level to the left-hand side in the Regal Metrology booth. So feel free to stop on by. I'd love to show you a demonstration, give you some hands-on on, you know, feeling like what the operator would feel like, opening the door, pressing the button, or putting the part in, pressing the button, seeing how that works. It's a nice system, very easy to use. Would love to show you more at the booth.
Are you working with any colleges or universities with the engineering students now, training them on this technology that's available to them?
So at this point, I think the biggest thing that would be good to train the kids on is the use of product and manufacturer information, how to start creating their CAD models with this, the dimensioning and tolerancing built in. But we personally are not doing that. That is kind of more of a Polyworks type of thing. From our technology standpoint, it's so easy to use, there would be very little training involved.
Okay, thank you.
Thank you very much.
Right. Appreciate it, Nate. Great job.
Thanks, Jim.
Outstanding. Okay, as we're going to just take a couple minutes here to transition to our next presentation. About now. Put Bill back to work. Okay, good morning, everyone. This is again session track C, session 1. We're Friday morning, the 19th of October, and we're doing our second product demonstration for this morning. I'd like to introduce Jeff Palmer from OASIS Inspection Systems, and he'll give us a quick presentation. And you also have a model available at your booth for demonstration. So, Jeff, hand over to you.
Thank you, sir.
Thank you very much.
Appreciate it. Well, good morning, everybody. I certainly appreciate the opportunity to be here to show you what we do. We are the OASIS Inspection System, and before I get to a video here, the OASIS is a 2D profile inspection system. We say that it's the industry's fastest because our measurement is instant. I figured I'll just start right away with the good stuff, basically. What we're doing here is we're going to measure 5 parts, 26 dimensions per part. That part's already been inspected. Operator places the part, clicks the data button, that part's been inspected. So our measurement is continuous. We don't scan the part, so that's how we're able to display these dimensions instantly. And on the right-hand side here where you see the status display bar, the green status display bars are good dimensions, red are bad, and we do also have a warning. You'll see the yellow status display bar at the bottom. It means that we're either getting close to the top end of the tolerance range or the low end. But this is instant feedback that we're giving our customers. So it's instant dimensions, pass-fail data instantly, so that our customers can keep track of their processes, basically. They can find out if a dimension is growing, if a dimension is shrinking. We see folks use our machine in a number of ways. Sometimes they use it when they're setting up when they're setting up a machine. We'll see them use it as a first piece or first article inspection, in process, final inspection, and also for incoming. Lastly, we also get feedback from our customers that they'll occasionally use it for sorting. So what we do need to do with the OASIS is create a program, because the machine's not intuitive. It doesn't know where to look and what the tolerance range is until we identify that. So here you can see that we don't run through the entire 26 dimensions here, but in very general terms, we tell our customers to expect a part program to take about 15 to 20 seconds per dimension to set a program up, and then of course they have that to use over and over again. Also, if you think about a real world or a shop environment, an operator can walk up to the machine. We do have a search feature where they can place a part, search, open the part program up, and inspect, again, in terms of maybe an hourly check, 10 parts in a matter of a minute or two. So the intention of the OASIS is, this here is basically what a complete part program would look like. Again, we have the upper and lower spec limits there. Dimensions can be edited so you can number your part program to more closely mimic what your part print looks like. So again, upper spec limit, lower spec limit. The actual measurement is in the column that says measured there, and we do again have the warning level set up. The little carrots or diamonds in the status display bars there show where the dimension falls in the control range. So again, you can kind of follow your processes in real time. So this is what the real-time status display looks like. I just kind of ran through that, but again, the red there, the caret or diamond is pinned to the right, so we know that's on the upper end, so we have a dimension that's growing. Now, with our system, we can have it right on the shop floor. So a great percentage of our customers use the machine right on the floor because that's where it's the most useful to them. This picture tells a lot of the story about our, and I'll move because I'm on this side. I don't want to block anybody. This picture I took last June, and I took it for a number of reasons. First of all, it was one of the very first machines we ever made. That was made back in late 2006. So the same machine is sitting on their shop floor, still performing its intended function, and has paid for itself, obviously, many, many times over. It's in a shop environment with oil mist. It's at home there. The OASIS itself weighs about 80 pounds, 78 to be exact, so it's very robust, and it is really a shop tool. The other reason that I like this picture is I like to be able to show folks that they can certainly have it on a cart if they want to move it around in the shop. In this shop, there were 2 operators that shared this machine, and they just kind of moved it on an as-needed basis. The other thing that I like to show about this is that this operator was doing his machine setup right at his machine. So he was taking the part out, putting it on the OASIS, and adjusting his offsets based on what the OASIS was telling him. No trips back and forth to quality. Wasn't leaning against the machine, waiting for the green light, or letting the machine cool down. So I like to show this video, and I'm not trying to get it to move here. What I like for folks to know about the OASIS also is that we can communicate with automation. We can send, in this case, we were just sending a pass-fail signal to a robot. You see the OASIS there. Gripper's out of the way, pass-fail is sent, off it goes. So we can send that pass-fail signal to a robot, or for our customers that may have comp software on their machines, we can send the dimensional data so that the offsets are adjusted on the fly. The OASIS is, some of the benefits are similar to what Nate mentioned earlier, in that the training is minimal, and we're taking the skill level required and minimizing that. A couple of case studies that I'll talk about before I talk about our rotary stage there is, I've recently had a medical company come to us with instruments for eye surgery. They were about 6 inches long, and all they cared about was what was on the end. We built a fixture and held it, and they brought, pardon me, 300 parts with them. 300 parts, and they put it through the OASIS in 42 minutes. He told me that it took him 10.5 hours to do that conventionally, and that he had a 100,000 part backlog. So that was a really nice savings for that customer in terms of time, effort, et cetera. Also, we very recently sold a machine to a company in Ohio, a screw machine shop. Before they had any training, they just wanted to measure one dimension, a height dimension on a part. They created just a program with one dimension on it. They had an intern measure 3,500 parts. Guy had no skill whatsoever. He measured 3,500 parts and pulled 900 bad parts out before they delivered the parts to the customer. So well, let me back up here. One of the things that I wanted to talk about is that the OASIS, of course, is a 2D system. There are limitations with a 2D system, of course. What we did was we came up with a motorized rotary stage so that we can rotate the part. Now, one of the things I didn't mention in the video at the beginning was that it appeared that the part was on its side, but with our system, the part actually stands vertically. It's not defying gravity. It's not chucked. It's actually standing vertically, but we do have our camera rotated. So again, to address some of the limitations of a 2D system, we've added a motorized rotary stage so our customers can rotate their part. In this case, what we're going to do is show roundness of 2 diameters, and we're also going to look at the concentricity between those diameters. And it's very simple. I will, there we go. So what we're going to do is we're going to set the machine to rotate the part one time, measure it 30 times in that one rotation, 32, excuse me. Part doesn't have to be perfectly in the middle. In the upper right, we're going to count down backwards from 32 to 0 as we're rotating the part. So we're taking 32 data points. Now, we can't call this 3D measurement. It's not 3D, but we certainly can call it 360. And the information that the customer gets back, now instead of having a single diamond representing a single dimension, we're now displaying the min and max. So in terms of a diameter, we're showing the customer the roundness, and again, we're able to show the concentricity between those diameters, which is super useful to our customers, and in particular, the customers that are measuring cylindrical, symmetrical parts. A little bit more about our line. The Elite unit, the field of view that you just saw in those videos is 1 3/4 in part length, 1.5 inches in part diameter. So it's for parts that are on the smaller side. The Core X2 we see there is our largest system, and that's almost double. Now we go to 3 1/4 in part length by 2.5 inches in part diameter. So the setup is rather simple, and again, I mentioned earlier about how the image appears rotated, but the part is actually standing. So with the OASIS, the way that it's oriented, we have a distinct advantage over some of our 2D competitors, because most of our 2D competitors are vertically oriented, more of a microscope mentality, and they have as their stage a glass surface. So when you put a part like that on there with different diameters, it's not going to sit correctly. So then the part has to be fixtured, and that slows things down. So with the OASIS, we just put the part on the pedestal, get our hand out of the way, and we gain all of those dimensions. So we talk about continuous image acquisition. It gives us an advantage that we measure continuously. We don't scan. That increases our accuracy because a scan introduces variable resolution. What's variable? Who knows? So with us on the continuous side, it gives us an increase in accuracy. We measure actually at a rate of 6 times per second. This system is accurate up to plus minus 1/10, or that's what machinists say, 1/10,000th of an inch. And let me just skip through these and just talk a little bit more about our capabilities. Obviously, we can, diameters are very easy for us, distances are very easy, angles, circles or larger radii. But some of the other capabilities that give us a lot of depth and eliminates our customers' needs for hard gauges in a lot of cases. An example is an offset diameter, where we're able to find the diameter at a specified distance from an edge. And then we also have a gauge line where we can measure a distance from an edge to a specified diameter. This, again, will eliminate a hard gauge for a lot of our customers, and that's we see mostly with the customers we work with that do ammunition, armament, those type of things, where they want to look at tapers and how tapers are graduating. The other thing that our customers love about our machine is our ability to measure 60-degree threads. The OASIS can measure the pitch of the thread, major, minor, and pitch diameter. And the last 2 dimensions there that you see, the crest and root truncation, is actually a calculation of the crest and root flats. So great capability here with the thread measurement. And when we add that motorized rotary stage, again, we're kind of eliminating some of the things that could be hiding from us in a 2D shot, and then giving you the full rotation. Of course, again, we're also able to measure metric threads, tapered threads, and reporting also is obviously a very important element with inspection. And now we're eliminating the pencil and clipboard. As you saw, all the operator needs to do is click the data button to collect all that information. We have an onboard report that we call the OASIS report. With a couple clicks of a mouse, you can convert that report to a CSV file if you'd rather have a spreadsheet. As I also mentioned earlier, this dimensional data can be sent out. We're able to interface with comp software in the case of offsets on the machine, or pass-fail in terms of a robot. Here also we have trace fields. You have 10 fields you could set up for just to give you more depth of traceability. That way you can drill down and find a certain inspector, machine the part came off of, a shift, and that's also where a customer, in terms of medical companies, could serialize their parts and the report. So this is what it looks like in Excel. The other important element of our machine is our customers can calibrate it themselves. We send a calibration kit with the machine, and our customers, our end users, don't have to have an outside entity come in. They certainly can, and some of our customers do, but sometimes all they need to do is send the pins out for recertification on every couple years. So that's basically the rundown of our system. It's a very simple system to use. Again, we're kind of taking the skill level down a notch because it is so hard to hire and keep good folks and to train them as well. So I'm open to any questions, and of course we're upstairs. I'd be anxious to show you, give you a hands-on demonstration that's a little bit more meaningful to see and touch it.
Jeff, I do have a question.
Yes, sir.
I saw the robotic arm.
Yes.
The interfacing. So could system then tell the robotic arm if it has a red or out of tolerance dimension to sort those parts for you, so you can acceptable parts would go to the left and bad parts to the right, or.
That's exactly right. Yeah, and we actually had that set up at IMTS where we had a certain number of bad parts and good parts, and we were showing the robotic arm taking the bad ones, placing them in a different bin than the good ones.
Excellent.
Yeah.
Any other questions for Jeff Palmer?
Well, thanks again for the opportunity to show you what we do. Really appreciate it.
Right,
Please
thank you very much.
don't hesitate to stop by.
Thank you.
All right, sir. Thanks again.